Okay, hello everyone, and welcome and happy new year. This is the first Convex stream of 2024, so it's going to be a super exciting year. We're going to be launching the Convex protonet in the near future, and a lot of exciting things to look forward to. So I thought it was worth spending this very first stream of the year actually looking back a bit and talking about how a bit more about how Convex came about and a bit more about the motivation, the inspiration, and the vision for Convex, and how that's developed, and how that's all sort of influenced the creation of Convex and the way that we've built some of the things as we have. So hopefully it'll be an interesting conversation. As always, we'll be live on chat. So if any of you watching want to fire in any questions, please do shoot them in, and I'll do my best to get to them as quickly as possible as we go through. Um, so I think probably to start off with is a little bit about the story of how I came to start the development of Convex and the research that went into Convex in the first place. Um, so I've actually been fascinated by decentralized technology since a very since the very early days, since my student days when I was playing around with the internet in the era of the dot-com revolution, and really looking at the protocols and things that made for an open internet that allowed the free exchange of information, that allowed the free exchange of data, and that sort of radical openness and transparency that created, in the end, vast amounts of value. Although perhaps in the early days of the internet, it wasn't necessarily quite so obvious where that value would come from. But it was all fundamentally based on having an open system that enabled the flow of information and made that accessible to everyone. And that, of course, changed people's lives, and it created a great deal of opportunities, and it created some great businesses that grew out of that. And I think net. I mean, you can obviously argue about the ills. I think the internet has done great things for humanity over the past 30 years. Um, Now, I think one of the things that's interesting is while the internet does this incredible thing for information and digital technology and the ability for things to operate in fundamentally new ways, a lot of the economic system has not adjusted to that age. A lot of economics still runs on very traditional mechanisms. We've had banks, we've had clearing, a lot of the financial instruments go back for years, well before the digital era, and are still fundamentally non-digital in nature. And even to the extent that they have been digitized, it's really just a digital tools helping to automate the old process. So banks, for example, are a classic example. The fundamental business of banks has not changed for hundreds of years, but they've put in IT technology. Some of them spend billions of dollars a year on IT to make that business operate. But it's still fundamentally a centralized financial institution that is, taking money in and giving out loans and operating in all those ways that these traditional financial institutions do. And I worked for many years as a consultant. I was a strategy consultant with McKinsey and Company, and we spent a lot of time going into these big organizations, helping to diagnose some of the problems they had, the challenges, understanding their opportunities, the risks, and what they could do to improve their operations and their organization. And a very consistent theme I always noticed was the vast amount of waste that went on in most organizations. And that came in many different forms, but huge amounts of money was spent on infrastructure, IT, finance. I mean, our rule of thumb was something like 5% of operating cost would normally be the finance groups in sort of general administrative expenditure, and that probably didn't include costs of things like credit card fees if you're in retail. Wouldn't necessarily include the cost of all of the transaction costs of negotiation of pricing in sales. there's basically these huge transaction costs every time you do any financial transaction, any economic transaction with money. And that affects big organizations like the kind we used to work with at McKinsey, but it also affects small operations. Yeah, I mean, how much pain do small businesses go through um, making sure that they chase up payments, or the accounts receivable functions, billing, invoicing. This is super inefficient. Yeah, and I've never seen a really good estimate, but it's probably not unreasonable to say that between 5 to 10% of global GDP is probably spent on economic transaction costs, broadly defined. Yeah, so that's credit card fees, it's the people who need to administer accounts payment, invoicing, finance, it's the cost of chasing up things, it's the cost of bad debt, credit references, credit checking, all of this infrastructure around payments. Indeed, a large proportion of the financial sector, the entire financial sector, is fundamentally just dedicated to managing transactions on behalf of their customers. So probably 5 to 10% of global GDP is tied up in these economic transaction costs, and that's a huge. That's first of all, that's a huge loss on society. Yeah, that's 5 to 10% of GDP that we could be spending on human flourishing, on improving the world in many different ways that we might all want to see. So anything that you waste is stuff that you can't use for good. So that in itself is a sort of tragic loss. But also it's hurting innovation. It's hurting the future. These are significant costs that make it hard to do business. And the harder it is to do business, the less innovation we get, the less chance we get for people to bring new products to market. The less chance we get for people to try out innovative new business models, etc., etc. And it particularly hurts small businesses and individuals and people who haven't got the economies of scale that large businesses might have. Yeah, I mean, invoicing may not be a big deal if you're a company that does 100 million invoices a year, but it probably is a pain if you're doing 5 to 10. Yeah, so this amount of waste is significant, and it holds back economic progress, which ultimately hurts all of us. And I see in the chat, yeah, I mean, easily agree that the waste is 5 to 10%. Yeah, I mean, it's hard to estimate, but certainly if you've spent a lot of time working in different kinds of companies, you'll get the feel that it's probably about that kind of level. If credit card fees alone can be getting up close to that kind of level. So there is a pain in the world. There is transaction costs, the cost of doing business, and all these economic costs that are fundamentally waste, and could in many cases be much more efficient. It probably can never be zero, but anything that is costing us 5 to 10% of GDP, if we can make that cost 1% of GDP or 2% of GDP, that's going to be a massive win. Now, in order to do that, of course, we need to digitalize the economy, and we need to take away some of the risks and frictions that make it difficult to automate or streamline these processes. And that potentially requires radically different ways of doing things. And the crypto revolution obviously started with Bitcoin and the idea of having a decentralized money, obviously illustrated one of the most important ideas, which is that of self-sovereignty. The idea that you can have money, economic assets, that you control on a personal self-sovereign basis using cryptography, rather than having a third party do that for you. And that's a big deal, because if you're interested in reducing transaction costs, you need to cut out activities that don't actually add value. And if you have person A and person B wanting to make a transfer of value between the two of them, but you have to involve 10 other companies in making that transfer of value happen, there's obviously going to be cost, there's obviously waste in all of that process. And what decentralized technology showed was that it was possible to remove all of that. You could have a direct peer-to-peer transfer of value. So I would describe this as an existence proof. Yeah, it doesn't prove that that is the most effective way of transferring value, but and I would argue that Bitcoin isn't for various technical reasons. But it does prove that it is possible to have peer-to-peer transfer of value with with um, without any middlemen, without any sort of centralized institutions getting in the way of that value exchange. Um, and then, of course, the next big innovation, and I perhaps shouldn't say innovation because these are a lot older, in fact. But the idea of smart contracts, of self-executing um, contracts, where people can uh, rely on the contract itself to execute and settle, is I think the second key plank, if you like, for being able to digitalize and create these sort of more effective open economic systems. And what smart contracts enable you to do is cut away all of the settlement activity and all of the work done to make sure that contracts get executed and complied with. And that takes a lot of work in many different companies, whether that's in procurement, whether that's in accounting, whether that's in um, legal fees and costs associated with contracting. So smart contracts again are this huge efficiency lever if you can move significant volumes of economic transactions into the into the digital realm and purely digital realm and have that all automatically executed. And smart contracts aren't a completely new idea, but the the and in fact smart contracts engines have existed for quite a long time, but as sort of proofs of concept. But it was really the fusion of decentralized technology and smart contracts that many people realize, oh, in fact, you can have these decentralized programs that are both executing contracts and transferring value in an economic system that's fully digitalized and is fully self-sovereign. So suddenly we're seeing a way to self-sovereign decentralized systems that are fundamentally more efficient than traditional economic systems. Um, question. Yeah, so decentralized tech was always always an interest, and P2P value caught the interest. Smart contracts really enables you to do a lot more with P2P value exchange. Yeah, so if you don't have smart contracts, you can maybe transfer some money, but that doesn't help you in enforcing whatever agreement that payment was meant to represent. The smart contracts can actually execute it. Yeah, so smart contracts really sort of make it so you can use decentralized technology for more than just a payment system. You can use it to actually run economic systems. So when I talk about open economic systems, I'm talking about systems where they're open, they're participatory, anyone can come in and use them. They are self-sovereign, and they're also economic systems. They're not simply payments. Yeah, and this is super important. The smart contract is what means that you can go beyond simply making a payment or a transfer into executing some complex arrangement. That might be swaps, it might be financial derivatives, it might be marketplaces, auctions, decentralized exchanges, prediction markets. It might be legal contracts for delivery. It might be purchase orders, invoices. There's a whole host of different things that you could put in that build in that category, and a huge space for innovation. But they all become possible once you have Turing complete smart contracts that can execute arbitrary logic in the execution of the code. So yeah, so that really was a light bulb moment for me. That okay, the planks are coming together that make a lot of this possible. Um, Question: is smart a good adjective to be used? Um, Self-executing may be better. Well, self-executing is generally accurate. Yeah, they generally do self-accurate. I think this is one of those terms that has now been used for so long, there's no point trying to change it. I think it's a pretty good adjective. It's smart. The contract is smart in the sense of the way that is an intelligent agent in its own right, or maybe not intelligent, but at least is an agent that performs actions in its own right. Um, so the way we describe these kind of self-executing agents in Convex, we call them actors. And the reason we call them actors is it's a bit of an aside, but I think a smart contract to me is an instance of an agreement. Yeah. So a contract might be, I pay you £100 sterling, and in return you're going to, give me an NFT or something like that. That will be an example of a contract, but that will be an instance of a contract. What you don't want is you don't want to have a completely separate economic agent for each instance of a smart contract. Yeah, you want to have an economic agent that is managing maybe tens or thousands or millions of such contracts. So we call that economic agent in Convex an actor. This is the self-executing code that it's a program, if you like, a decentralized program that is self-executing, that is autonomous, and does what it's programmed to do. And that might be managing many smart contracts. So the reason we distinguish between an actor and a smart contract in Convex is more of a conceptual thing. Yeah, the actor is the entity which is performing the execution of one or more smart contracts. And I think that's a useful distinction to make. That is a Convex specific term, but the word actor is used to define autonomous agents in other systems. So it's a pretty reasonable word to use here. Question: would atomic be correct? So atomic really refers to individual transactions. Again, we're diving a bit into the technical weeds here, but atomic means that either everything in a transaction happens and it succeeds, or if something fails or if something doesn't happen, you can roll it all back and nothing's changed. So either it all happens or nothing happens, which is important if you're doing something like a swap. Yeah, you don't want to give away your money and not get the money back. You want the entire swap to be successfully completed. If it doesn't get completed, you want your money back. Yeah, so atomic is important in that respect, but a smart contract is more likely to be a long-lived thing. A contract might last 10 years, and there might be multiple different transactions that happen during the lifetime of that contract. Yeah, there might be some interim payments, there might be a refund processing service, there might be a termination clause that would also be executed. And those will be different atomic transactions throughout the lifetime of the smart contract. So I would say, to be accurate, a smart contract is a logical entity that represents some economic arrangement or some agreement between parties. And there are transactions that are atomic that happen at various times during the lifetime of that smart contract. And those transactions, if successful, may update the state of the smart contract. If unsuccessful, they get rolled back and nothing's changed. So that's how I would use the word atomic in this context. One more question. Ethereum opened the door to smart contracts, but why did Convex need to come to exist? Okay, great question. And so I started looking at Ethereum quite closely. I was a CTO of Ocean Protocol. So Ocean Protocol was still is, it's still going, a project looking at data ecosystems and how you can create decentralized data sources and supply of data, and for money. Yeah, so you could tokenize data assets and other kind of data related assets. So we did an extensive evaluation of all of the of many different tools and utilities and mechanisms for building decentralized systems. And this was back in 2017, 2018. And one of the problems was they all had their flaws. Ethereum has very high transaction costs, and it's also pretty slow in the sense of how long it takes for a transaction to actually execute. And these are the two things we really care about. Yeah. What do we care about as a user? If you're trying to run some smart contracts, if you're trying to interact with some decentralized economic system, you fundamentally care about, you know, three things. First of all, does it do what you want? Yeah, does it have the capability that you want? Yeah, whether that's a swap or an auction or stuff like that. But from a technical perspective, you're interested in how much did it cost me? Yeah, if it's going to cost a lot, then you haven't really saved anything. Yeah, there's no point, saving $10 of centralized processing fees if you're going to pay $15 on transaction costs on a decentralized system. Yeah, you've not gained anything. It's no better from a cost perspective, and the cost of switching over may have cost you even more than that. So unless you can offer a significant win in transaction costs, it's not actually that very compelling. And that's a big problem for many projects, because typical your typical investor doesn't care about paying $10-20 on a transaction, but your typical user in the economy, your normal purchaser, your person who's going to be making small payments in retail, for example, they're not going to accept high transaction fees, and it basically kills a whole lot of business models if your transaction fees are high. I'd argue, in fact, it kills most business models. There's not actually that many business models other than high net worth investing that that can really survive with very high per transaction fees. And it was also, I mean, more of a personal thing, but I really care about sustainability. And if you are burning vast amounts of energy running these proof of work systems and other inefficiencies in some of the decentralized platforms that we see, but proof of work is the biggest problem. You're doing incredible environmental damage, and it's not clear that you're actually helping anyone by supporting or using such systems. So, I always felt Ethereum was great in that it had proved the model of being able to run smart contracts on a decentralized system, but wasn't really ever going to be acceptable for mass adoption. And the other thing that I think is really critical for mass adoption is latency. So what you care about as a user is from the time that you say yes to your transaction, that you click the button saying buy, how long does it take for that transaction to be completed and confirmed? And that has to be pretty quick to offer a good user experience. And people are used to credit card payments going through in a second or two. Yeah, and they're not going to accept having to wait a minute to confirm some blockchain transactions, and some systems obviously take a lot longer to confirm than that. Yeah, so Bitcoin famously is pretty long transaction confirmation times, and it's even once they're confirmed, they're maybe not confirmed because you could have a 51% attack and it could get rolled back, etc., etc. So these confirmation times and the latency that it gives to users is a big problem. Again, if you want it to be adopted broadly across the economy, you can't have these systems that have got these really long time delays between taking an action and having a confirmation of the result. So those struck me as like two fundamental problems that plagued nearly all decentralized platforms. And there were some other minor issues, I would say. I mean, if you look at things like the capabilities of the programming languages and what you can actually do within these virtual machines, they're quite restricted compared to what you can do in a more powerful, like in a conventional programming language or a general purpose programming language. The platform, the runtimes for smart contracts had quite a lot of limitations. And I'm not just talking theory, I'm talking more generally. Yeah. So okay, there's probably better ways of executing some of these things and being able to program these things effectively. So that was a sort of maybe a more secondary point to the transaction costs and latency. And then what were the solutions to those at the time? Well, there were lots of people creating new kinds of solutions to that. Um, layer twos were probably the dominant sort of approach. Yeah, let's just move it off the main network and run a little side network. Well, then you've got a couple of problems. Yeah, first of all, you've got the problems of um, you've now isolated your transactions into a separate ghetto. Yeah, you suddenly haven't got the ability to do atomic transactions with the main state. And that, of course, stops you from doing things like atomic swaps, and many smart contracts don't work if you've got to cross across two different consensus networks. So that was always somewhat unsatisfactory. And they also, these sort of L2 sidechain kind of approaches end up pretty centralized. Yeah, you got them if you're running a side chain just for a specific project. You've got this problem that it's got centralized control. Yeah, you're pretty much tied in with this one project or this one system. You know, which it's got pros and cons. Yeah, I mean, it gives you some degree of agility and some degree of assurance that if things go wrong, it can get fixed. But it's also not good if your aim is to create an open, free-flowing digital economy, which is certainly what I thought was needed, or what we needed to move toward. So all of this basically led me to really dig into how do we find a better solution. And those of you who've joined the Discord and chatted about these things on other calls will know maybe fundamentally, and what Convex provides is a much more efficient consensus algorithm, convergent proof of stake, which really solves the latency and transaction cost problem. Yeah, it means that you can basically settle transactions near instantaneously, certainly sub-second, and you can give that really compelling user experience. And it also gets the transaction costs really low. Yeah, so we needed a better consensus algorithm, and one of the observations was that blockchain was never going to do it. Yeah, blockchain has these fundamental limitations that means you're never going to get to really low latency, because you've always got this problem that you have to build a block on a previous block. Yeah, and what Convex lets you do is lets lots of transactions flow in parallel from many directions. There's no bottleneck of having to wait for one block before you produce the next block, and that's fundamentally key to enabling low latency. If you can't remove that bottleneck, you can't get to really low latency. And Convex removes that bottleneck, which is one of the key innovations. So Convex is not technically a blockchain. Yeah, we don't chain blocks together in the way that a blockchain does with a hash of the previous block, which enables us to get consensus to run in a much more efficient way. The consensus actually is kind of more like a conflict-free replicated data type, or CRDT. There's lots of clever maths behind it, how it works, which is in some of my other talks. But it basically lets us get to consensus much more efficiently, much faster. And it uses basically zero energy. It's super efficient. The amount of processing is minimal. So you're really only waiting for the time for the messages to get around the network. You're not waiting for any processing to happen on the consensus to any meaningful extent anyway. So the consensus algorithm is key to getting the latency and transaction costs low. And then there's also the virtual machine, and the Convex virtual machine is really about giving more power to developers of smart contracts. And why is this important? Well, as I say, there's limitations on what you can do with many of these decentralized virtual machines. And the CVM is designed to be a much more powerful engine for sophisticated economic systems. So we're talking about smart contracts that manage other smart contracts. We're talking about decentralized governance. We're talking about much more sophisticated interactions between different kinds of digital assets. All the things that we might want to see or want to make possible in a fully decentralized digital economy. The CVM is designed specifically to provide those kinds of capabilities. So that's the fundamental technical pieces of Convex that make it very different from the existing solutions. Questions from the chat. Why doesn't that get spoken about more often? The problems relying on a previous block. Um, I'm not sure people have thought about it enough. I think people haven't really. I think there's not been enough emphasis on low latency and user experience in the crypto space, because most of the current crypto users are not using it for retail consumer like applications. Yeah, they're doing maybe some trades, but they don't mind waiting a bit for the trade to get confirmed. It's not top of mind. And obviously, if you are a blockchain system that has bad latency, you're not going to talk about it. Yeah, because you know it's a limitation, you know it's a problem. So these things don't get amplified as much as I think they should, because ultimately users only care about, as I say, doing what they want, doing it fast, which is low latency, and doing it cheap, which is low cost per transaction. So um, yeah, I mean, yeah, it should be talked about more. I mean, I think people who've worked in the web know that every 100 milliseconds of time that it takes for a web page to load loses you customers. I think Google's probably got the best research on this, but they literally prove that you can statistically show you've lost customers for every extra 100 milliseconds that someone waits for a web page. So it's fundamentally important, this sort of responsiveness, this interactive experience, to give a good sort of consumer um, um, adoption. And that's what Convex is designed for. Yeah, it's designed for being able to support um, interactive consumer level applications that do need fast responsiveness. So there's a reason we've done it like this, yeah, and that we put a lot of effort into all the engineering to make that possible. Any other questions? Wouldn't the people interested in DeFi and not blockchain maxis have found this? Yeah, I mean, I think it's interesting. I mean, I think there's many different schools of thought on DeFi as well. Um, so it depends what you think DeFi is. Yeah. So I think more about economic systems than finance. Yeah. So how do you actually enable more efficient transactions in a digital economy is, to me, more important in the long run than how do you finance things. Finance is just part of an economy. Yeah. Debt, investment, loans, all of this kind of thing is ultimately how you fund the real economy. I'm more interested in the real economy ultimately, because that is where economic value gets created. Financing is just how you move the money around to fund value creation. So finance is important, but I think economic systems are more important, if that makes sense. Um, Another question: how important is it to be permissionless and leaderless? So by permission, so leaderless is the same thing as not being a blockchain. So leaderless is um, if you have a system that requires a leader to produce a block. So any blockchain has to have ultimately a leader that produces a block, or a block producer, call it what you like, but someone has to produce a block. Yeah. And then that block then has to be published so that other people see the block, and then other people can add their next block on top of it. Yeah. So that is super important. Being leaderless is essential if you want to get really low latency, because if you have a leader, you've fundamentally got this bottleneck of having to produce a block, and uh, then the delay that it takes to propagate that around the network, etc. Permissionless is more about decentralization. So if you want a truly decentralized network that is self-sovereign and that anyone can participate in, that's when permissionless becomes important. Yeah. Do we want to allow anyone to run a node on the network, to run a peer on the network? And I think this is important. I think it is. Um, I think if you want to create a fair economic system, you have to allow people to participate on a level playing field. And that means you shouldn't be giving, special privileges to certain actors or certain parties, like approving a list of validators, which might be convenient. It might make some people happy, but I think if you're following the real principles of being genuinely open and generally participatory, you want to let anyone come in and use the system. So I think it's an important aspect of decentralization to be permissionless, and the governance that entails. Um, it's not essential, and you could argue that users don't care. Yeah, as long as they can do what they want to do and they can do it fast and they can do it cheap, maybe it doesn't matter. But if you're centralized, then you're not really realizing the vision of a truly open economic system. Yeah. And it's a particular problem if, like, for example, we can do everything that Convex does could have been done 20 years ago in a centralized system. Yeah. Google could have done it. Yeah. They could have built the Google smart contract engine and put a big smart contract engine behind it and run it on their cloud servers around the world. And it could have done smart contracts. It could have done digital currencies. It could have done tokenization, NFTs, you name it. Yeah, a centralized system could implement something like Convex, and have that all run by one company. Yeah. Um, the problem is if you have that level of centralization, you've got no guarantee that someone won't pull the plug at some point. Yeah, they might decide, hey, actually, we want to bring this down for whatever reason. Yeah. um, and then the other the other thing is it can be censored. Yeah, if they decide they don't like a particular participant, they can say, okay, you're not allowed. Yeah, they could ban competitors and stuff like that, and you could then create this sort of monopoly power situation. And you also lose trust because ultimately a centralized company can go in and edit the database. They can move assets around. They can, steal money. They can, take 1 cent off every transaction. They can do whatever they like. 'Cause it's a centralized database in that context. So I do think decentralized is important if you are to remove the risks and costs of having centralized power in economic systems. So that's why I think it's important. Um, and that's more of a long-term way that we want economic systems to operate rather than a immediate operational constraint. But I think it's still very important in the long term. Um, does permissionless means that AML and KYC fails? No, not necessarily. I mean, you have to ask what requires AML and KYC. So AML, for those who don't know, would be anti-money laundering, and KYC would be know your customer. So AML and KYC, unfortunately, the regulation is a complete mess, and it's different everywhere in the world. But plenty of things you can do have zero money laundering risk. Yeah, and plenty of things you can do don't require you to know your customer's identity. Yeah, if I sell you a sandwich, I don't need to get your ID. I shouldn't need to get your ID and to validate you that you've got a valid passport. Yeah. A lot of the economy should not require you to identify yourself every time you do an economic transaction. That's a gross invasion of privacy, and potentially also a huge risk at some social and political levels. So um, so I would disagree that AML and KYC should be embedded throughout the whole economy anyway. Yeah. Now it does obviously belong in some places, but the question is where. Yeah. And if it is important and if it is needed, then yeah, I mean there's good reason to put in regulation like that. But I think it needs to be measured, it needs to be based on risk, and it needs to be applied at the right points in the system. And the permissionless parts. Generally, KYC doesn't work on permissionless parts, but AML might still work. Yeah, because permissionless just means that anyone can participate without identifying themselves or without getting pre-approved. it it doesn't mean that there isn't transparency. Yeah, and I think transparency enables AML even in a permissionless context. Yeah, you can see how funds flowed, and you can see who took the funds out and who put the funds in. So I think you can still do AML and KYC. I mean, particularly it's at the edges. Yeah, it's like the exchanges, and people are doing swaps for fiat currency that it's more likely to be important for, rather than the truly decentralized part of the economy. Um, when did Rust become my language of choice? Oh, that's a deeply technical question. So I partly like Rust, and I partly don't. So I do think Rust is a beautiful, elegant language. It is quite close to the metal. So if you want to write um, stuff that you might have used C++ for in the past, but you want a much nicer, cleaner language, and you want memory safety specifically, then Rust is actually a really great choice. So if you're writing system tools for your machine, or some kind of some low-level code that requires a little server process, Rust is a really good language for some of those kind of things. What Rust doesn't have is full automatic memory management, which is the primary reason that we build on the JVM for Convex, is because automatic memory management is extremely important, and at a certain level of system complexity, it's a performance advantage. And this is getting to really technical stuff, but garbage collection that you use in an automated memory management system is faster than alternate methods of managing complex data structures, which would primarily be things like reference counting. So there's an approach called reference counting, where you basically do this accounting of how many pointers point to the same thing, and it works, and it's an effective system, but that is more expensive and slower than garbage collection. It's better just to let the things get swept away once it's no longer referenced. And Rust really doesn't support garbage collection very well. It does have reference counting, but as I say, once you hit a certain level of system complexity, the costs of that start to become significant. And I think Convex is in the spot of a sufficiently complicated system that it's better to have a garbage collector than to do reference counting. The other advantage, of course, on the JVM is just the huge amount of stable libraries, for crypto and for networking and all of this kind of stuff. So the JVM is a very good system for building the base Convex peer. Having said that, I think Rust is an absolutely fantastic language. I do want to have a good Rust community and libraries working with Convex, and there's nothing to stop Rust being the language of choice, I think, for people building systems that interact with Convex. I would say on languages, Convex is very much designed to be language independent. So you can use whatever language you want to talk to Convex. There's libraries for C, Lua, Java, Python, JavaScript, ClojureScript, and you can do it with basically REST API calls. So you can basically interact with pretty much any tool that can make API calls. So Convex is kind of very flexible, and we're language agnostic in terms of what system you use what languages you use to build on top of Convex. This Convex virtual machine is also language agnostic in the sense that it is a virtual machine that you can build different language front ends for. So you can have different languages that you then compile down to the CVM operations, which is kind of like the machine code on the CVM, which is what actually gets executed when people interact with smart contracts and stuff like that. Now we do have Convex Lisp as like the main language that we've been using so far to develop smart contracts, but there's nothing to stop people creating a different language front end for the smart contracts and the sort of the on-chain aspects as well. So again, part of being open is you've got to allow it's got to be an open system, means everyone's got to be able to connect to it. It's kind of like the internet, yeah. Doesn't matter what language the web server is written in. What matters is that many different people can build different systems in different languages that all know how to talk HTTP. They can all make web requests. They can all interact with that service. Yeah, and it's that kind of spirit of the open internet that Convex is trying to embody here. Would someone be able to use Solidity? Yeah, there's no reason why you couldn't do a Solidity to CVM compiler, with the exception of parts that are very CVM or EVM specific. Yeah, so the CVM has some things that don't have an equivalent in the EVM. So that would be a bit different. And also the way that you specify addresses. So addresses in Convex are basically numbered, whereas in the EVM you've got like that sort of public key account address. So there's some differences between the runtime, but the language itself, yeah, you could absolutely create a Solidity to CVM compiler. That would definitely be possible. I mean, we have an experimental language that one of our developers built a couple of years back that was kind of a JavaScript like language that compiled to the CVM. So we know it's possible. We do have sort of some prototypes that show that you can do that kind of thing. It's really, do people want to use them and develop them? And it is of course all open source, so anyone can build different language front ends if they want to scratch that particular itch. But as I say, from a vision perspective and from an overall what we're trying to do with open systems perspective, we are technology agnostic in terms of what people want to use. Great questions, by the way. I mean, we sort of gone a little bit into the sort of technical side rather than the sort of economic system side. But these things have to come together, yeah, because ultimately we're building technology which is going to support these open economic systems. So just quickly looking at notes. Yeah, so I was going to go on a little bit of a side if people are interested on, a bit of economic theory. Oh yeah, so good question. I wrote a manifesto. We can go through the manifesto. Actually, that's a good idea. I'll just show people that and some of the ideas that we put in that. Let me just bring that up 1 second. Okay, so this is Convex Manifesto. It is available in the Convex Dev organization. It's part of the design repository, and it's in the papers section where we've got a few sort of written papers on various different topics, including the sort of the Convex white paper. A manifesto. So the aim here was to sort of lay out some of the sort of principles that we've tried to embody in the project, and that what we want to achieve. So I'll just run through the highlights of this because it's it's a medium length document. But open economic systems, I think I've talked a bit about that. The primary purpose is to create economic systems that are efficient and support all the kind of the value creation we want to see in the world. It's about value exchange ultimately. How do people come to mutually beneficial agreements that create value and do that in an efficient and effective way? A belief is that participants must be self-sovereign, so that it's an important freedom, and it's important to remove the risk of high transaction costs and the costs of middlemen and stuff like that. If people can freely control their own economic life, yeah, their digital assets and the transactions that they participate in. So self-sovereignty is important. As I mentioned before, sustainable is critical. We don't want to build a system which uses unsustainable amounts of resources to operate and maintain. We want it to be the most efficient system for value exchange. And I'm pleased to say I think we're getting pretty close to that, because it is shown to be super energy efficient in some of our trials with the European Union, and it's effectively close to zero energy costs per transaction, which is going to be cheaper than pretty much any other alternative out there. It's going to be cheaper than centralized economic systems, and it's going to be more sustainable than decentralized systems that use less efficient approaches. Fair access, so everyone should have equal access to the mechanisms of value exchange. No one should be excluded from participating in the economy, and that should be direct. They should be able to go direct and interact with the economic systems that they want to participate in, whether that's currency exchange, whether that's taking out loans, whether that's participating in auctions, whatever it is. You should be able to access those directly. Now, obviously, people will use tools, user interfaces, to facilitate their access. But that should be open. Everyone should be able to do that. And if you don't like the tools, you should be able to use your own, yeah, or indeed go down to the tech level and do it with direct commands if you want. But that access is critical. Real time, so I talked about low latency. Having real-time transactions is absolutely fundamental if you want an efficient and fair economy. Global state. This is a slightly more technical thing, but this is about the idea that all of the assets and smart contracts need to be able to talk to each other. We can't have a whole bunch of different islands like with blockchain L2s, where there are significant costs or architectural constraints talking to different smart contracts or transferring across different assets between different islands. Yeah, it's got to have this global state if it's going to be truly effective and not have all of the security risks and extra costs associated with bridging across different systems. And if any of you follow the security space, you'll know that about half of the major crypto hacks are compromises on things like bridges. So while bridges are somewhat inevitable in a multi-chain world, you want as few as possible, and certainly we'd like as much as possible everything to be operated in a global state model. Programmability, so again we talked about the virtual machine and the ability to build powerful smart contracts. Transparency, I do think transparency is important. Everyone should have the data about what's going on in the economy if they want to analyze it, and it should be auditable and it should be verifiable. Yeah, a lot of governance depends on can you actually verify and audit things. So transparency is critical. Cost effectiveness, obviously you want the transaction costs to be negligible, so that the typical user doesn't have to worry about transaction costs whenever they do anything. It must allow people to create their own digital assets. So it can't be restricted saying these are the only assets that people can ever use. You've got to enable this sort of blooming of different types of assets that serve different purposes in the economy, and enabling that innovation and again being open to new types of assets and new approaches is going to be critical. We're building something for the long term here. Yeah? We're not going to hard code in assumptions about the kind of assets that people might want to use for time. That's going to change, so we need flexibility for that. Open architecture, so as I mentioned, inspiration from the internet. It should be an open architecture. Everyone should be able to connect, everyone should be able to participate, and everyone should be able to use whatever technology they want to talk to Convex. Open source, so again all the source code for Convex is on GitHub, and all of the tools and all the things that we develop at the Convex Foundation that interact with Convex will also be open source. So I believe it's a most effective way of developing robust, trusted software. as a development approach, but it's also giving users freedom. Yeah, if you want to fork it and do something different or create a new tool, building on what other people have built, then this helps to enable all of that. Network neutrality. So I guess this is the analogy of we treat all users equally. Yeah, the network should not discriminate between users or applications, providing they're fairly following the rules of the protocol, and etc. etc. So kind of like, you know, so there's always a debate about telecoms providers having network neutrality. They're not censoring, they're not interfering, they're not discriminating across users. Is I think quite an important principle for. Oh, hi, Nicholas. Good to see you here. Yeah, so network neutrality is again in the manifesto. Freedom to operate a peer. So anyone may operate a peer on the network. This is part of being permissionless. You know, as long as you follow protocol rules, you're welcome to run a peer and, you know, help to validate and run the consensus of the network. Manifesto says that we will have a native currency, the Convex coin, which is like the utility token that enables you to use the network and is accessible as a sort of a currency for built-in protocol related functions. Yeah, so most primarily executing transactions, staking on peers, etc., etc. Now, you kind of need a native currency in the protocol because the protocol has to manage resources. Yeah, if you make resources completely free, then you're completely open to denial of service attacks and these kind of problems. Yeah, people can go and consume infinite resources. So we need a way of denominating the resources of the network, and that's the Convex coin. Community recognition. So how do we distribute the Convex coin? Yeah, this is a digital asset. Ultimately, it is a resource, and it is potentially valuable. So how do we distribute it? All Convex coins get distributed on the basis of contributing to Convex. Yeah, and this is without exception. Yeah, it's every coin will go through this route. So the two ways of getting Convex coins, well, you can either be a purchaser of coins, so you can either purchase coins and contribute financially to the Convex Foundation, which is a not-for-profit foundation, which you know has a mission to develop Convex and support the ecosystem, or you can contribute in non-monetary ways, either as a software developer or as a community member or as you know, helping us to fix bugs on GitHub, many different ways, and you know we give out grants of Convex coins to anyone who helps the community or the ecosystem. But all Convex coins get initially issued as community recognition. Yeah, in one of these ways. So either to coin purchasers or to community contributors, and then after that, of course, they're free. People can use them as they wish. Yeah, they can transfer them. They can stake them. They can give them away. They're the possession of one of the initial recipients. But that's how we basically get the coins out into the ecosystem in the first place. And then governance. So a point about governance. You know, we're governing Convex in long-term interests of its users as a public utility network. So it is serving the public. It's a utility network. It lets people do things on top of the network as a public service, and that's effectively the mission of the Convex Foundation is to facilitate that. So I mean, hopefully they're good principles. I mean, it is on GitHub. If anyone wants to come and propose edits or suggest some changes or improvements to the manifesto, that's super welcome, and that's, you know, that would count as a valuable contribution. So you know, feel free to you know, chip in on any of the sort of ideas that we're developing. It's a living document, yeah. So if we think there's good improvements we can make, let's do it. Other questions? Tell us about your time at Cambridge. Oh, I probably not got vast amounts of time to do into that. I will mention one. I did rowing, so I was I quite enjoyed rowing. So a good way to keep fit. I wasn't such a fan of the early mornings, but you know, there's nothing quite like, you know, going down to the river at 6 a.m. with a bunch of teammates and you know, pulling out the boat and, you know, going for a 2 hour row down the river. And you know, won a few races. So I was never tall enough to be one of the really top tier rowers, but I certainly enjoyed it. And you know, I think it's always good to have a, you know, a balance of life. So in between, like fanatically reading about economics the the underlying technology of the internet, you know, getting out and doing something deeply physical was you know, kept me fairly happy. Um, I will say I'm happy to chat about more on some of the other channels, but um, yeah, that's one snippet. Um, Other questions. Is it true that all peers in the global network will all have synchronized in 1 second? Yes, less than 1 second, hopefully. Um, uh, Rather, they are, yes, they any single transaction should get synchronized, and the result of that transaction should get synchronized in less than a second, for sure. We have had it down to as low as 300 milliseconds for global networks, which is, you know, pretty much limited by the speed of light at that point. Um, and we also have zero block delay, so any peer can initiate a consensus, new transactions going into consensus basically instantly. Um, and they should all have synchronized on the results of any transaction within less than 1 second in, you know, 99.999% of cases of time, absent, you know, major network disturbances or stuff like that. What I would say is Convex is a little bit clever in that they will never necessarily completely in sync. Yeah, so you might have synchronized on the results of the transactions from half a second ago, but there may still be some new transactions pending. So there's always going to be a little window of transactions that aren't yet fully synchronized. But there will be a time window after which everything's basically synchronized across all peers, and you know, about half a second hopefully is going to be our average. And that's probably synchronized. Yeah, that's not. We think it's synchronized. It's actually the peers have confirmed that. So. Oh, Nicholas, also a rower. Fantastic. Kayaks. Oh, good stuff. Good stuff. Sea kayak is a lot of fun. Um, okay. One other question. How do you set up token supply release to ensure sustainability? Um, so there's when you say token, is there's the convex coin itself, yeah, and there's what I would call tokens that are generated on the network. So anyone on Convex can create their own token, yeah, and they can become the issuer of that token, and they can grant themselves, you know, token minting rights, and they can mint as many as they want, yeah, and that is a fundamental feature of the network, and anyone can do that, and you know, that's up to the users to decide how they want to how they want to do that. For the convex coin, so we sort of have I probably don't have time to go into the full details, but we have a um, we have a system where convex coins get released as the ecosystem grows. Yeah, so there's actually a market determined release mechanism, which I think is a cool economic mechanism that releases convex coins as demand in the ecosystem increases. Yeah, so we didn't want to sort of say, okay, well, all the coins that'll ever exist get, you know, issued to, and I think this is a problem with many crypto projects. Yeah, if you look at many crypto projects, a very large percentage of the coin supply or the token supply or whatever goes to founders to early investors, or or some of the whales. Yeah. So you've got these huge centralized vested interests in each of these platforms, and not much left over for regular users. Yeah. And it becomes a game of, and this is why pump and dumps happen. Yeah, it becomes a game of how can you pump something up and then dump it on the retail users. And we wanted something better than that in Convex, so we have a sort of economically determined release curve, which basically allows for us to hold back the majority of the potential maximum Convex coin supply until the Convex ecosystem has grown to the point where it can reasonably absorb those coins. So that's the economic idea behind the Convex release curve model. It is a kind of an interesting model. A bit too technical to go into right now, but I do think it's a good model, and it should ensure the long-term sustainability of coin release. Oh, that's a cool suggestion. We should make a repo for awesome Convex people can post their project. Yeah, that sounds a really good idea, actually. Yeah, so have a if it's helpful, we can set up a page for that in the design repository. Yeah, because we already have the design repository, but there's no reason why we can't say ecosystem and just list ecosystem projects in there as part of the the broader design context. Because design doesn't mean Convex core alone. It's about the whole ecosystem. So yeah, very happy to do that, and then we can take pull requests on things people are working on and want to publicize and want to link to. So great idea. Would releasing Convex coins after launch devalue people's coins? No, and this is the genius of the release curve. The release curve only releases coins at increasing price. So you can guarantee that people can't buy the release coins from cheaper than the last people got them. So the release curve can in fact never devalue coins. It can only ever release coins when the value is going up. So yes, that's the cleverness of the release curve system, and it does it. I mean, it does avoid pump and dumps. It really, I think, is a fair way of releasing coins. A bit hard to get your head around in the first place, but I think it's actually a very fair system, and it is of all the systems that I looked at, it was the most consistent with our sort of values and principles that we have a fair release curve. So. Okay, great stuff. Thanks for all the fantastic questions. Hopefully, this has been an interesting call for everyone, and shared some of the sort of ideas behind Convex, and also reflecting some of the ideas that people have had in conversations throughout the past couple of years. So thank you very much for all the great questions. Going to sign off now, but if you want to continue the conversation, I'll be on the Discord, so feel free to drop by there, and see you all again soon. All right, bye for now.